Hello everyone, my name is Atefa Amlashi and welcome back to A4Q Testing Summit. We are approaching to the end of this summit but we have some great session ahead. In this session, I'm pleased to introduce Wim, with difficult last name, a passionate software testing expert with more than 20 years experience, mainly in financial sector. Wim is deeply involved in the testing community as he is one of the co-author of ISTQB CTFL 4.0 syllabus and also test analyst and agile tester syllabus. Agile tester is a recently launched certification from ISTQB. Hello, Wim, and welcome. In today's presentation, Exploratory Learning Style, Wim will explore how different learning styles can improve exploratory testing. As always, we encourage everyone to stay engaged and share your question or feedback via chat or in the comment with us. Please do not forget to vote for Wim if you like his presentation. Please join me in welcoming Wim. Wim, stage is yours.
Thank you, Atefa. Let me quickly grab the right screen. So, welcome in my session or my talk on exploratory learning styles. Now, before I'm diving into the subject, which clearly relates to exploratory testing, of course, let me introduce myself. My name is Wim, and as Atefa said, I'm one of the authors for a couple of recent ISTQB syllabi, and I'm also an expert test consultant for Access, a Belgian IT consultancy company. I'm a loving father. I'm happily married, as you can see in the top left corner, and I'm also a retired Boy Scout. I even managed to become one of the trainers for junior Boy Scout and Girl Scout leaders in Belgium, training them everything or teaching them everything they need to know to be good leaders. I'm also a huge trans head. I'm overly excited that Tiesto finally has come back to his senses and came back to trans. But enough about that. That is not what we're supposed to be talking about today. For my talk, I invited 6 friends, and you can see their pictures over here. And the first one of my friends is Christopher Columbus. Now, why did I invite Christopher Columbus for my talk? The reason is that Christopher Columbus is seen as one of the first or one of the most known explorers on the planet or in history. And since exploratory testing, the word originates from exploring, I thought, well, let's investigate what exploratory testing actually is and who can help me better with this than Christopher Columbus. Now, Christopher Columbus discovered America, but how did he manage to do so? You should know that in the days that Christopher Columbus was living, it was the 15th century, people still believed that the earth was flat. Some minds were already advancing and thinking differently, but for most people, the earth was still flat. And in those days, we also had different kingdoms trying to conquer the planet. You had the Portuguese kingdom, the Spanish kingdom, and they all tried to conquer as many different countries as possible to set up trade routes and so forth. And at that moment, the Portuguese were in the lead. The Portuguese, they had already discovered main parts of Africa, and they managed to do so because they discovered something which was called the passat winds. The passat winds allowed to go very fast, very far with your sailboats over the ocean. Now, that was one element that was needed to discover America. The other thing is that you should know is that Christopher Columbus actually was a librarian. He lived between his books. He lived for his books. And what do people do that live with books? They read them. So Columbus got in touch with a lot of great works from ancient history. He read work from ancient Greek scientists like Ptolemaeus. And Ptolemaeus already proved in one of his works that the earth was actually round. And for Columbus, something connected. And he thought, well, if we can sail very fast over the ocean. And if the Earth is round, then maybe we can go around the planet to find a new trade route to that country that Marco Polo was talking about, China or something. So Columbus, he set up his master plan and he went to visit the King of Portugal and he asked, well, can you give me some ships and some money? I'm going to find a new trade route to China. The answer of the king was very simple. No. So Columbus went to the King of Spain. Can you help me? The answer was no. King of France? No. King of England? No. Portugal again? No. Spain again? Nope. Wait. The next day, the queen told him, well, actually, I want to be your sponsor. And she gave him ships. She gave him 3 ships, the Santa Maria, the Pinta de Nina, and she gave him a bag of money, and she told him, go find me that trade route to China. And Christopher Columbus sailed off. And he did discover China, or that is what he believed. What he actually discovered, historians think that he discovered the Bahamas. And he also discovered Japan, because Marco Polo told about an island not far away from China, which was called Japan. And he also discovered thus Japan. But people now think that he landed on Cuba. And Columbus, he thought, well, those Chinese and those Japanese people, they're a little bit weird because they walk around naked. But who cares? I found my trade route. So he went back. He was a big hero. He promised everybody cities of gold. And we know what happened next. Now, going back to this story of exploration. If we look at exploration, and if we look up the definitions of exploration, there are many different stories, many different explanations for what exploration actually is. And if you Google this, if you look on Wikipedia or you ask ChatGPT, it makes things only worse. But all of those definitions, they have some things in common. And the first one is that you need focus. For good exploration, you need to be focused on your goal, knowing what your goal is and trying to do everything to get to your goal. Also important is perseverance, that you're not giving up trying to reach your goal. Columbus had to spend over 10 years trying to convince those different kings to give him some money. But he didn't give up. You need curiosity. You need to be curious to figure out what is out there. And especially in those days, when people still believed that the earth was flat, you also need courage. You need courage to continue to sail, not to fall off the face of the planet. And the last thing you need is optimism. You need to believe in your goals. You need to believe, I'm going to make it. When I saw this definition, I wondered, does this sound like exploratory testing to me? And the answer was actually no, absolutely not. Because there are some things that I just cannot live with from a testing perspective. And the first one is optimism. Because optimism for me, from a testing point of view, comes with confirmation bias. That you're only looking for things that work. You're only doing happy path. Hey, my code works. Confirmation bias is typically attributed to developers. They test until they can prove that their code works, and then they ship it to the testers. And the testers do all the negative testing. But negative testing, you cannot call that optimistic. And that courage part, I also don't like it. Because courage comes with taking of risks. And testers are usually risk averse. They can live with a small risk, but big risk, and especially those where you can fall off of the face of the planet, doesn't sound like something a tester would do. So this definition of exploration and exploratory testing, it doesn't fit me. So I continued my search. And my search led me to my second friend. My second friend is Roger Bacon. And he was already off the planet. He already died 200 years before Columbus even walked the planet. And Roger Bacon, if you don't know about him, don't worry, it's not that important. But Roger Bacon is known for experimentation. He's seen as the founding father of the concepts of experimentation. And if we look into the Oxford Dictionary for a definition of experimentation, we can claim that experimentation is the activity or process of trying or testing new ideas, methods, etc., to find out what effect they have. I already like this definition, but let's look in a little bit deeper into what experimentation actually is. And experimentation is actually related to the scientific method. Scientific method, again, if you never heard of this, it's not a problem. If I'm explaining this, you will probably say, yeah, that makes sense. It's actually the process that any scientist, any college professor, and so on follows to do scientific research. Now, what is the scientific method? It has 5 steps. The first one is that you need to define your question to investigate. And for those of you who had to write a master thesis, there you also had your question to investigate. From that question to investigate, you're going to create an hypothesis. You're going to create an idea. There's a correlation between these data elements, or there's a logical relationship. If I do more of this, it will be less of this. You will have an hypothesis. And then you need to do an experiment to measure whether your hypothesis is correct or not. So you're going to gather data. And once your experiment is done and you have your data, you're going to analyze that data. And it's important, of course, with the experiment that your experiment is not biased, already directing you into a confirmation of your hypothesis. That is cheating. That is not scientific. You're going to analyze that data, and from that data, you're going to draw conclusions. Conclusions as in, my hypothesis is correct, or my hypothesis was incorrect, or almost correct. And usually the hypothesis then needs to be redefined. And when I heard about this, I said, well, yeah, this is actually the same thing what we do when we test. Defining your question to investigate, that actually matches with defining what is the scope of testing. What functionality, what feature am I going to test? You're going to have an hypothesis. You will have some ideas of how the things will work, how it will function, or what the results will be. Gathering your data, that's actually performing your test. Analyzing the data is looking at the test results. And I'm not talking about pass, fail. I'm actually talking about what is occurring. What is the actual result in ISQB terminology? And from that, we will learn something. We will draw conclusions. Whether the actual result actually matches the expected result. Maybe we had the wrong expectations. That's also something you can learn. But we have that learning part. And as you remember, it is part of my title of this session. So I want to dive deeper into that learning part. But first, I would like to introduce you my third friend. And my third friend is Cam Kaner. And people who are into exploratory testing most likely have heard of the name of Cam Kaner. Cam Kaner is, together with Michael Bolton and James Bach, seen as the founding father of exploratory testing. And Cam Kaner created different definitions of exploratory testing. It came in different versions, and the last one is currently the version that we are using to define exploratory testing. And what is exploratory testing according to Cam Kaner? Exploratory testing is simultaneous learning, test design, and execution. The execution part, yeah, that is clear. You're doing your testing and you're seeing what the results are. The test design, we can also imagine during exploratory testing what that means. And we're coming up with different cases that we would like to investigate. These are the hypotheses that we create and the setup to gather the data for our experiment. But the simultaneous learning, that is where a lot of people struggle with. If I ask, I've given a lot of trainings, if I ask people, explain me exploratory testing, I get a lot of different explanations, typically using words like randomly clicking some places, just trying out things, just exploring, wandering around. But the learning part typically doesn't come out of those definitions. Well, actually, this is the core part of exploratory testing, because it is the learning, doing the analysis of what you've seen or what you've experienced, to redefine your hypothesis. That is an essential element within exploratory testing, within the scientific method. So that learning needs more depth. So what is learning? Again, the Oxford Dictionary. Learning is the acquisition of knowledge or skills through study, experience, or being taught. Most people, when they think about learning, they think of being in a classroom, being taught. And then afterwards, they have to study for an exam or prepare a task or something like that. That is learning. But that's not the only way of learning. Learning can also happen through experience. And learning is not always formal. If you're in a classroom, if you're in a training room, or even if you're attending this conference, this is a form of formal learning. The organizers of those learning sessions have set up everything so that you have the optimal ability to learn something. But what you learn, I cannot fix that. I cannot make sure that you will learn what I want you to learn. I can only hope for that you will learn or get the insights and the knowledge that I would like to share with you. Let me explain that with a small story. You remember from my introduction that I said that I was a coach, a trainer for junior Boy Scout and Girl Scout leaders. And we used to do different, I'm going to say training sessions, but it's not really trainings. And on one of those sessions, what we did was we did role playing. We had a group of junior leaders and we did role playing out in the real environment. So we did role plays in the forest, we did role plays in a city, we did a role play in a supermarket. And for that role play, some of them took up the role of being a kid with a certain problem, like running away or missing their mommies. And others one had to take up their own role of being the leader. And they had to deal with the situation. And then we discussed and evaluated and looked at what were the lessons learned. Now, after an entire day of doing all of those role playing, me and my we asked our participants, what did you learn from today? What is your biggest takeaway? And all of them were answering, yeah, I've learned this and that, and things that we wanted them to learn. But one answered something completely different. And it still stuck with me. Because he started telling a story about something that we didn't plan for. In the supermarket, he saw a toddler running away. And he saw the mother of that toddler chasing her toddler and just distracting him with something fun. So he got away and he was no longer looking at the stairs. She didn't shout at him, hey, watch out, or something like that. She just distracted him. She played airplane with him and put him in the other direction, and he ran back into the store. And that is what stuck with him. He said, that is what I learned, that you don't always have to shout things like watch out, but that you can also distract kids out of dangerous situations. And that's something that stuck with me, that somebody can learn something completely different than what you've planned to learn from. Learning is something personal. Okay. We know now what learning is, and we know that learning is more than studying or being in a classroom, but how do we actually learn? Well, we learn through our senses. We have 5 different senses that collect inputs for us to learn. Some people have a 6th sense, but if you can see dead people, maybe you should see a psychiatrist. What do we do with all those inputs? Well, to explain that, I have another friend of mine. And Paul Gerard, he's a personal hero of mine. Paul Gerard is a tester. Well, actually, he used to be an engineer, but he's gone completely into testing. And he has done a lot of interesting things for the testing community. He was even a speaker at the A4Q Testing Summit. I don't think this year, but the past years, he was also present. And Paul Gerard, he came up with a model. He calls it the new model of testing. And you see in this model a lot of arrows going back and forth. I'm not going to explain all the details of his model. You can see the link on the screen. It's a YouTube video in which Paul, the master himself, explains exactly how this model works. But what is important for you to remember, to understand what I tried to explain to you, is that testers create a mental model of the system they're testing. And they do that based on the information they get from the different oracles, like requirements, but also just oral feedback they get from other testers and from the PO or whatever. But they also do this with the information they get from their tests. So the feedback they get from the system, the outputs, the result they get out of the system are also used to refine the mental model that testers make out of the system. And it is that model that is then used again to do better testing. And this maps onto the scientific method, because the mental model is actually your hypothesis that you create. And from that hypothesis, you're going to test to make sure that your model is correct, that your hypothesis is correct. And you will get results. And if those results are not correct, you have to redefine your model. You have to redefine your hypothesis. See how everything is connected? Okay, so we know now what we do with the inputs. We create a mental model. But how do we process those different inputs? For that, I have yet another friend. And if you have read the abstract of this talk, you would know that I was going to bring in David Kolb. Now, David Kolb is not a tester. David Kolb is more into psychiatry and so on, and he's famous for his theories on learning. And one of his models is called the experiential learning cycle. Now, how does this learning cycle work? Very simple. You can experiment something. For instance, you're touching an electric wire. And from that experiment, you might experience something. You might get an electric shock. And most likely, you don't think that is pleasant. So you have a negative experience of touching an electric wire. So you're going to reflect upon that. Was it a good idea of me to touch an electrical wire? Well, probably if it's not connected to a power source, then it's not a problem. So you're going to conceptualize. You're going to learn something out of this, and you're going to make a concept. And you say, well, I can only touch electrical wires if they're not plugged in into the power source. That is a flow. But a flow is not a cycle. Okay. We can translate this flow into things that you do. And from those things that you do, you will feel things. And from the things you will feel, you will do an introspection. You will watch and look at the senses that you have triggered and what you can reflect upon. And you will think about it. You will conceptualize, you will come up with an idea. And as said, this is a flow. It's not a cycle. Why is this? Because it should be a cycle. Very simple. Do, feel, watch, think. And from this learning cycle, there is no starting point. I explain it with a starting point that you experiment something and that you will then experience something. But actually, in the learning cycle, you can enter at any point. It can also be that you just experience something and that you don't know where it's coming from. And then you will reflect upon it, you will make a concept, and you will try it out. Was this the reason why? So there are different entry points. And every person has a preferred entry point in a learning cycle, meaning that every person has a preferred learning style. For the different learning styles, you could say that people who are somewhere having an entry point mixed between feeling and watching, those are people that like to gather information. As kids, they are the ones that ask millions of questions. Why is this? Why is that? What happens if I do this? Why isn't it this? They like to gather information. That is their entry point into the learning cycle. If you're more into watching, thinking, you like theoretical concepts. You like to read books. Theoretical concept, this is what I love. The different models that I'm showing you, I can look at them for hours and trying to fully understand them. That's my entry point into a learning cycle. Between thinking and doing, you're more into finding solutions. You like to solve problems. You like to think of how can I tackle this problem and that problem, trying to come up with a solution. That's also a very nice entry point. And a lot of people are more into doing and feeling. They like to do things hands-on. They just say, forget about the manual. I don't want to look at instruction videos. Just give me the thing. Let me try it out. Research has shown that the majority of people are hands-on learners. Now, I said this is an entry point and it is a cycle. To get a full learning, you should actually go through the 4 steps to have complete mastery of something, to completely master a certain piece of knowledge or a certain skill. So whatever your preferred learning style is, your preferred entry point, if you really want to master something, you also are going through the other steps to make sure that it really is your own. Okay, having explained this, I would like now to map this onto exploratory testing. And we start with people that are working hands-on, because majority of people are hands-on learners. Hands-on learners, what they try to do is they try to recognize things. What do they try to recognize? Well, defects. You're testing and you want to recognize defects. It would be stupid that you're doing certain actions and you don't see the problems on the screen. They also want to recognize interesting items. I would like to investigate that a little further. Not now, but in another session. And recognize questions. Yeah, that's interesting. I should ask the developer about this, or the PO, or the UX designer, or whoever is involved. You also want to recognize dead ends. Dead ends in the sense that I don't need to further explore this part of the system. I've done enough. It's okay. You want to recognize patterns. Hey, the behavior on this page looks similar to the behavior on that page, and on that page I have that action. So let me try it out if I can also do it here. So what you're actually looking for is that you want to recognize behavior. That is typically the entry point for people that are hands-on testers, hands-on learners. They're trying to recognize behavior by interacting with the system. People who have an entry point of gathering information, obviously they're going to ask questions. Who is using the system? You try to understand the different personas, the different stakeholders that are involved in the process to know what is important to test. What does the system actually do? What are the features of the system? When will the system be used? That is also an important question. Is it a 24/7 service, or is it only for a ticketing site, only when there are new tickets available for a new show of a certain artist? Where will it be used? Is it an app for booking transportation in a city? Yeah, then it will be used probably out in the open. But some apps or some applications are used deeply underground where there's no internet connection. Those are questions you would like to ask. And also, of course, you ask for the why. You want to know what is the value of this system. And all of this helps you to understand the context, to understand how and when and why the system will be used. Because if you have an answer to these questions, you can put yourself into the persons, the users, their shoes, and you can empathize with your users and thus test more from a user perspective. But these are not the only questions to ask. There are more questions that you would like to ask. Huh? Really? And so? What you do as a tester is that you're going to challenge whatever is on the testing table. Do we really need this feature? Yeah. And who is waiting for that part? It's okay to challenge the requirements, because by challenging them, by really challenging, does this have any value? You can try to improve the quality by not including features that nobody needs. People that are into theoretical concepts, their testing approach is most likely that they're going to read and review. What are they going to read and review? Yeah, of course, user stories, API descriptions, requirements, UX designs, the manual. They're going to do a lot of reading and reviewing. And why are they doing this? Because they're looking for facts. They need knowledge. They need knowledge to base their model, their mental model upon, and to have a correct model. But they're also reading and reviewing, sorry, that's the wrong button, to ask the question, what is missing? They want to know what is missing from these requirements. You do reading and reviewing to improve the requirements and to say where are the contradictions and to look for facts to get understanding. But you also do reading and reviewing of those different work products to get an understanding of what is missing here. What pieces of information do I also need to get a better mental model? So do both. People that are into theoretical concept, they also like to investigate. What do they investigate? Assumptions. Assumptions made by themselves, assumptions made by the developers, assumptions made by the business. Because we all know, or I hope you know, that assumptions are a tester's worst enemy. Never assume. You should know. You're going to investigate your developers. How do they work? Are they vibe coding or are they doing it themselves? Are they junior developers? Are they senior developers? How long are they already working on this project? What is their style of doing development? Do they write their own unit tests or did they just throw it over the wall? Those are things you want to investigate. You want to investigate the history of the system you're testing. You want to know what were problems in the past, because there's always a likelihood that they will reoccur. You're going to investigate the platform on which your system should be working, because there can be triggers that might trigger failures in your system. You're going to investigate the language, not only the programming language, so whether it's Java, Python, .NET, but also the languages of the system itself. I come from Belgium, and here typically, especially if these are government websites, they need to be in the 3 official national languages, meaning Dutch, French, and German. You also need to look at those things. And you're also going to investigate your data. What is the data that is needed for this system, and how do I get this data? Can I generate this with the help of an LLM, or do I need to go for scrambled production data? And is that still representative of the actual data that will be used in the system? Or do we need to do a data migration first? You need to investigate your data. And why do we do this? Because we want to investigate risks. We want to know where things can potentially go wrong. So we can also assess how bad are those risks, and we can balance our testing based on those risks. People that love to find solutions, well, they're typically going to brainstorm. What are they going to brainstorm? Well, obviously the tests that they would like to perform. But there are more things that they would like to brainstorm. For instance, test tours. I don't know if you're all familiar with the concept of test tours, but test tours is something, and sorry for the name dropping, that originates from James Whittaker. James Whittaker used to be head of testing at Google, used to be head of testing at Microsoft. James Whittaker wrote a couple of books that are also cited in different ISTQB syllabi. So he does know what he's talking about. And a test tour can be compared to a city trip. If you go to a city trip to one of your favorite European cities, for instance, to Barcelona or to Rome, you could go for a highlight tour, just visiting those elements that everybody says, this is what you must see. So you could test the highlights of your system, the selling elements, the things that marketing is most proud of. But there are other tours that you can do. You could, for instance, go for a back alley tour. And what is a back alley tour? Well, the locals in a city are typically not using the main roads. They're using the back alleys because that goes a lot quicker. So maybe you can also try to figure out, what are the shortcuts in my system? How can I do things faster? Or you can go for a wrong tour. So a wrong turn tour is is that you always do the wrong thing. So whatever you're on a certain page, and you definitely are not going to fill in all the mandatory fields, but you're doing something else. You're doing it wrong. You can get into very interesting results. And there are many different other tours. You can always dive into this in another moment. More things you can do are using mnemonics. You can brainstorm mnemonics Mnemonics are some donkey bridges. These are abbreviations where every letter stands for a different word, and a different word is then a different perspective on your system. One of the most known mnemonics used within testing is San Francisco Depot. And San Francisco Depot comes from James Buck. I remember one of the friends of Ken Kainer who came up with exploratory testing. San Francisco Depot is from James Buck. And San Francisco Depot, well, the S in San Francisco Depot stands for structure. What is the structure of your system? How is everything connected? What are the different components? What is interacting with what? What are the adjacent systems? The F is for functions. What should my system do? What shouldn't it do? The D is for data, already discussed. The I is for interfaces. What are the different interfaces, APIs or user interfaces that my system has? The P is for platforms, already discussed. O is for operations. 60% of an IT budget on average goes to operations. So it is something important. So what is the viewpoint on operations? How easy is it for them to keep your system up and running and to maintain it and to install updates and so on? And the T is for time. Is anything related with time? And it goes beyond just time behavior as performance, but other things with time as well. You're going to brainstorm checklist. Why did I include checklist? Because the focus sometimes is too much on creating test cases, while a lot of test cases can be replaced with checklist. And the advantage of checklists is that you can easily spread them. You can print them out, share them with your colleagues. Your colleagues can enhance your checklist, can reuse them. It's very easy to use. And when you're testing, you can just put the checklist aside and just say, check, this is okay, check, 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 check. Very easy instead of input, action, expected result. Use checklist. More things to use, more things to brainstorm, heuristics. Now, heuristics, not everybody is familiar with the concept of heuristics. So I'll try to explain what a heuristic is. If you would have to solve a puzzle or a Sudoku puzzle, for those that like to play this, and I would ask you, how do you start? What are the first actions you typically do when you have to solve a puzzle or a Sudoku puzzle? Different people have different starting points. Well, that order of steps to start solving that puzzle is their own heuristic on tackling that problem. And we as testers, we also have our heuristics. If we have to test, for instance, an input field, we're already trying out some things. That's our heuristic for testing an input field. And the more experience you have, the bigger your heuristics will be, the bigger your set of heuristics will be. So try to grow your set of heuristics. And you can do that, and that is why I put the lamp here. You can do this by talking to your peers. Ask your peers, for instance, what defect made them most proud? Because you can learn from this. You can learn from other people's stories because that will help you to enhance your set of heuristics. And before you start typing the question, I'll share my story. The defect that makes me most proud is a defect that is already detected more than 15 years ago. I started my career testing ATM machines, doing money withdrawals, cash deposits, and so on. And on one of the cash deposit machines, I detected a very nasty defect. What is the problem? Well, you might not be aware of that, but it occurs quite often that people forget to take out their notes when they do a withdrawal. And the ATM machine will then swallow those notes and put them somewhere separate in a different compartment. And an ATM machine, or at least the ones that I tested, they had 2 of those compartments. And then it would go out of service because it could not store any more forgotten notes. Now, what did I detect on that cash deposit machine? That if the second timeout occurred and the second time those notes got swallowed, the entire balance of the ATM machine would get transferred to that person's account. Meaning that if you would let the ATM machine swallow your 50 euro note that you've withdrawn, you would get an amount of tens of thousands of euros transferred to your account. Now, that is a defect that would have cost the bank a lot of money. So I was very happy to have detected this. And I said, it's 15 years old, so don't try it. Banks are aware of this problem now. Why do I share this story? What is there to learn? Well, look at timeout behavior. Look at repetitive timeout behavior. Try not to do things and then see what the system does. That's a heuristic. Try it out yourself. Okay, so the people that want to find solutions that are brainstorming, what they're looking for are strategies. They're looking for strategies on how to test, on how to perform their different experiments if we go back to the scientific method. And if we put it all together, we can go back to our cycle and hands-on, they are looking for to recognize behavior. And important to notice, even if this is your preferred learning style and your preferred way of testing a system, remember you have to go through the entire cycle. So do other things as well. I hope you were inspired by the ideas I gave you to have other ideas on how to test. Asking questions about to get to know the context, asking questions to challenge is another way of doing exploratory testing, but it should not be the only thing you do. Reading and reviewing to get to know facts and to just figure out what is missing. Again, another way of doing testing, but again, it should not be the only thing you do. Investigating risks, important, but do the rest as well. And brainstorm your strategies. So try to go through the entire cycle. You don't have to go and do these things in this order, but do more than what you're used to, than what you're comfortable with. And to conclude my story, I brought a sixth friend. And his name is Rob Lambert. And Rob Lambert is also a tester, or he used to be, because now he's more into management consulting. And he has a very interesting newsletter. I can recommend subscribing to Rob Lambert's newsletter. And in one of those things, in one of his newsletters, I read this: knowledge is information plus action. What Rob was trying to explain is you can collect a lot of knowledge. Yeah, I know how to do these things. I know what I should do in this situation. And from what you've learned, what I hope that you've learned from my session, is a lot of information. But you also need to put it in practice. Take the action, because only then you will master it. Go through the learning cycle, make it something you own, make it your knowledge. And if you want to go deeper into the subject of exploratory testing, I can recommend you the ISTQB Certified Tester Advanced Level Test Analyst, or the Agile Tester, the one that got recently released last month. Not only because I'm one of the authors of these things, but also because they're very good syllabi, also covering aspects of exploratory testing. If you want the references for the pictures, you can find them here. And then I think it's time for Q&A. Thank you.
Thank you very much, Wim. Very insightful session. I really enjoyed the storyline. Thank you. So now we can see if we have any question. I can see we have some question. Before opening floor for the question, do not forget to vote for Wim if you like his presentation. And the
1 out of 10.
And the first question, what is the most important takeaway from your talk?
Most important takeaway, you all have your preferred styles of learning, preferred styles of testing. Expand your toolbox of techniques, of things that you can do. I've shared a lot of ideas. Pick the ones that you find interesting, try them out, and expand your toolbox to become even a better tester than you already are.
Thank you. What is the impact of AI on exploratory learning?
Yeah. AI is always coming back in every topic nowadays. AI systems always also have to learn, but I'm talking about human learning. And the impact of AI is actually close to zero. You can use AI to enhance your testing, to speed up certain testing, but the learning as a tester, to create your mental model, like Paul Girard would say, that's still something you have to do yourself. And maybe you can try to learn an AI system to create a mental model for yourself, but then you're really making yourself obsolete, so don't go that direction.
Okay, thank you. Do your ideas also apply for the test automation?
Yeah. For test automation is for me a supporting activity. So if you're doing exploratory testing, you can quickly automate a certain script to do some investigations that you're doing quicker. So do these things apply for test automation? Test automation is a means, not an end.
Okay. Thank you very much. Thank you again for this insightful session. Vote for Wim if you like his presentation. You can find also his page on our website. And if you miss any session, if you want to share this session with your colleague, friends, the recording is available on our YouTube and our website. We are approaching end of the summit. Almost still we have some presentation until 8 p.m. But I want to thank my colleague also on the backstage, Kenza, Paul, and Issa. Thank you again, Wim, and thank you everyone for joining, and enjoy the rest of summit.
Bye.
Meet ISTQB Prep. Designed for future ISTQB certified testers, ISTQB Prep gives you everything you need to prepare effectively, from realistic exam simulations to AI-driven insights. Practice like it's the real exam. Get timed ISTQB-aligned tests featuring official sample questions so you know exactly what to expect. No more second guessing. Receive instant feedback with clear explanations, helping you understand why an answer is right or wrong. Stay on track with detailed performance analytics. Pinpoint your strengths, identify areas to improve, and watch your confidence grow. Get access today through GASQ or ISQI, whether as a standalone prep tool or bundled with your ISTQB exam. Study smarter, boost your confidence, pass your exam. Start preparing with ISTQB Prep today.